Okay, so in chapter 6, section 1, we got introduced into similar polygons. What's true about two similar polygons? Lewis.
Their angles are the same and
Which sides are proportional?
Good. Okay, corresponding angles are the same, and then their sides are proportional. So number 1 says to determine whether the polygons are similar. If they are, write a similarity statement and find the scale factor of EFGH to KLMN. The first thing I got to do is match up. Obviously, the angles are matched, right? Like I got one arc, 2, 3, 3, 4, and 4. So I know all the angles are already congruent. Now I've got to match up the sides. So I'm going to pay attention to the order of the letters. It says EF would match KL. So EF should go with KL. FG would go with LM. FG with LM. GH would go with MN. GH with MN. And EH with K and EH with KN. That way you know what sides to match up. Sometimes these are turned around. This time they're not. They're a little bit easier to read. But they sometimes they're harder to figure out what matches up. So if I did that, I should get 30 to 15 should equal 16 to 8, should equal 22 to 11, should equal 26 to 13. And what's true about each of these?
2.
They all simplify to 2 to 1. 2 to 1, 2 to 1. They all have to, so be careful because you could get one that does not. You got to check them all. So because these do all simplify to that same scale factor, these are similar. So EFGH is similar, which is that little squiggle, to KLMN. And the scale factor would be 2 to 1 or 2 to 1. You could write it either way like that. It can't be 1 to 2 because of the order of the letters, right? You said this one to that one. So you want to make sure you go in the order that it's asking. Questions on that one? All right, 2 says in the diagram, triangle DEF is similar to triangle HJK. Find the value of X. So if these are similar, then DF matches HJ, EF matches JK, and DF matches HK. So which of the side lengths, and we can go by color, which of the colors do I have values for both? The red one, right? So if I wanted to say DF, and it actually doesn't matter which order I'm going to set it up as long as I'm consistent. If I did the left triangle to the right, it would be 12 to 8. And that would be 3 to 2. Good, that's my scale factor. So then any side in the large one, like X, which is there, over its corresponding side, which is 9, would be equal to 3 to 2. And then from here, you can just cross multiply.
18 is 2x.
27, right? 27 equals 2x. And then divide both sides by 2. That's okay. So 27 over 2, 13.5 or 13.5.
Is it okay if we leave it as a fraction?
Yeah. Most of the time, if you were to see this on like a standardized test or multiple choice or anything like that, it usually puts it in mixed number because it's talking about a side length. So just keep in mind those would be the same. Questions on that one? Okay, number 3 says 2 similar triangles have a scale factor of 5 to 4. Find the ratio of their corresponding altitudes and medians. So an altitude would have the same.
Teachers and students present.
Okay, it's because it's just like the ratio of a side length. These should be the same, which means that both the ratio of the altitudes and the medians would be what? 5 to 4. Good. Okay, and then the last one says 2 similar triangles have the scale factor of 3 to 7. Find the ratio of their corresponding perimeters and areas. So what do we know about the scale factor and the perimeter? They're the same, right? So perimeter would also be 3 to 7. But if you think about what would happen if I had area, right? So if I had whatever the shape is, if the ratio is always 3 to 7 and 3 to 7, what would I do to get the area? Multiply 3 times 3 and 7 times 7, right?
Yeah.
So what's the ratio of the areas?
3, what is it, 7 or 3 times 2 or something? Or no?
You're going to multiply 3 times 3, which would give you 9, and 7 times 7, which is going to give you 49. So it's actually 9 to 49.
Oh, you just
So you would square the scale factor is what you're basically doing. So whatever the scale factor is, so if it's A to B, okay, it's going to be the same as the ratio of the perimeters. But if I want to compare the ratio of the areas, we're going to square them both. Because it would be length times width, so it would be two sides that you would be multiplying together. All right, so 24, the directions on there said that in the diagram, triangle ABC is similar to DEF, and 24 said find the unknown side lengths in both triangles. So the first thing you had to do was set up your ratio. DEF would have matched this side, which was unknown. EF would have matched BC. Those are the ones you know both of. So it said ABC, which is the one on the right, to DEF, which means 19 and 4/5 would go over 22. So when I convert 19 and 4/5 into a mixed number, it would be 19 times, into an improper number. It'd be 19, right? So this would be 95 plus 4, 99 over 5 over 22.
Wait, why over 9? Over 9, right?
Is the bottom 9?
Yeah.
Did I write it wrong? No. It's 19 and 4/5, right? So we multiply the 5 times the 19, that's 95. Add the 4, that's 99, but it goes over the same base. So it should stay over 5.
No, but why is the denominator 22?
Because, oh, that's what you're saying. This is because I picked the wrong side. Yeah. Thank you. So that should be over 9. And then we're going to do keep, change, flip. So the 99 over 5 stays. This instead of division becomes multiplication. And then 9 over 1 would be 1/9. So 9 goes into 9, 11 times. And my scale factor is 11 over 5.
I forgot to do the keep, change, flip.
Oh, okay. So then once you get that, you can do 11 over 5 equals anything in that left triangle over the right triangle. So if you're trying to find AC, right, it goes with the 10. So this could be your x over 10 and 2/5. So then that becomes 11/5 equals x over, this would be 50 plus 2, 52 over 5. Cross multiply and I get 11 times 52 over 5 equals 5x. This becomes 572 over 5 equals 5x. Divide both sides by 5, which is the same thing as multiplying by a 5th. And then if you divide that into it, that's where that 22 and 25ths comes from.
Yeah, I didn't call the keep, change, flip.
Okay. So then you're good on ED because it would be the same. Okay. All right, number 19 said the black triangles are similar. Identify the type of special segment shown in blue and then find the value of the variable. So if I know that these are similar, this one's similar to this one. Obviously, this length would match this length. This is going to match this length. These are kind of like twisted. So 18 to 27, 9 goes into both of those. It'd be 2/3. And then if I want to find the length of the altitude, I have to do 16 to x. So this is times 8. This would be times 8, which means x is 24. And then it says identify the type of a segment. So this goes from vertex, perpendicular, which means altitude. Any other questions from the homework before we move on? Okay, so we're not going to take notes or anything like that on 6.2. The only thing that's different in 6.2, it kind of like makes sense because it's similarity, but it goes back to transformation. So we talked about rigid transformations in like the chapter before last, right? Where you could rotate it, you could reflect it, and you can move it, right? But it kept the shape the same. Do you remember this? Those are called rigid transformations. Just know that it exists. Again, it won't be on your test or anything like that. But there's a dilation, which means that it changes the size of the angles, the size of the lengths of the sides, but it keeps the angles the same. So it preserves the angle measurements, Okay, but it results in the lengths being proportional, which means you are making similar triangles, basically, or similar shapes. That's the only thing that's in that section that could even like appear on a standardized test or something like that. Like it's not going to appear on the test in here. But that's all that it means. You're no longer preserving the shape, which means they're not congruent. You're preserving the proportional sides, which means that you're making similar triangles, okay? But that's the difference between rigid, which we had done before, and then the dilation.
Oh, so you're just making the sides proportional so then it can be similar?
Exactly. So you're making like a little scale model, making it a little bit bigger, a little bit smaller, keeping the angles the same, but the sides would be proportional, which is similar. Yeah. Okay, so we're going to eventually learn 3 ways to prove that triangles are similar. Today's the first one. So these are not your side, angle, side, angle, side, hypotenuse, leg, because those were proving that 2 triangles were the same. Now we're saying they're not the same, but they are proportional. And the first way is angle. So the angle similarity postulate says if 2 angles of one triangle are congruent to 2 angles of a second triangle, then the 2 triangles are similar. Again, not congruent, but similar. So if I have 2 pairs of angles marked as congruent, I know that these 2 triangles are similar. And you want to pay attention to the order of the letters, because if it has 1 arc, it has to match one that has 1 arc. If it's got 2, and then obviously the third that's unmarked would match. So in this diagram, triangle ABC is similar to triangle DEF. Camilla. Sort of. So you would know all 3 angles are congruent, and then you'd always have a fixed ratio of sides. Yep. So now we're just going to apply it. So example 1 says tell whether the triangles are similar or not similar. So in A, there's nothing marked as congruent, but what's on there that we can use? Parallel lines. So if I have 2 parallel lines, like this one and this one, and I look at first the left transversal, are there angles there that could be congruent?
Yes.
Which ones? Or what kind of angles? Corresponding. So like if this was 1 and this was 2, I would say 1 is congruent to 2 because of the corresponding angles postulate. Right? Alternate interior would bring you to the outside of the triangle.
Oh,
Yeah. But now we can use the same parallel lines but a different transversal, right? Like now I can use that transversal. And I also have corresponding angles on this side, like 3 and 4. Those would be congruent to each other. Again, corresponding angles postulate, okay? Or I could have used the angle at the top because it's part of both, which would have been what? Reflexive. Good. So that tells me that yes, these are similar. And it would be, yeah. So all we know right now is A, similarity. So you can't write, remember how we used to say, you can write similarity. You can, like with side, I told you you could just put SSS. The similarity, you need the word similarity. So A, similarity. How about B? Are these 2 triangles similar?
Yes.
Yes, same thing, right? 1 angle matches this, and this matches this. So again, angle, similarity. Then I go to C.
No,
Why not?
because there's only 1 angle.
Good. Only 1 angle. There's no vertical angles. There's no reflexive angle. There's nothing else, okay? So this would be no. But what else do you know about that triangle? So 2 congruent triangles similar?
No.
Are they?
Yes, they are.
So this is actually yes.
They are.
Okay? If they are congruent, they are similar because all of their angles would match, right? All of their sides would be 1 to 1, which is still a ratio. So if you can prove it congruent, you can also prove it similar.
And wouldn't the ratio just be 1 to
1 to 1. Yeah. But that's still the same ratio, right? Okay, how about D?
No.
Now it's no, right? This triangle has 1 arc here, right? This triangle has 1 arc here, but wait. What else is happening there?
Reflexive.
There's a reflexive angle that is shared by both, which now means
Yes.
so be careful. Sometimes they look it and sometimes they don't.
Yeah.
Wait,
So the big triangle here, has an angle that has 2 arcs and an angle with 1 arc, right? And the small triangle
It's like a rotation.
has an angle with 2 arcs and an angle with 1 arc. So they're not like aligned the right way, but if I took that little one and I pulled it out and I flipped it, it would look.
And which ones are flexes?
The angle at the top. Or no, sorry, the angle at the left. They both have.
It contains both triangles.
This angle is in both triangles, right?
Yeah.
Questions on those? All right, example 2 says find x. So the first thing we want to figure out is, are these similar? Obviously, if they're asking us to find x, they probably are. We've got our corresponding angles. This one would match this one, and this one would match this one. So they are similar, which means that the ratio of these side lengths would be the same as the ratio of the big triangle side lengths, okay? So if I wanted to set up a scale factor, which is what you want to do, the ones you have both values for are on that left side. So if I wanted a scale factor of the small triangle to the large triangle, it'd be actually 3 to 4. Yeah, so you got to get that whole side. And that's going to equal the right side of the small triangle, which is 5, over the right side of the big triangle, which is x plus 5. Good. And then I can cross multiply. 3 times x plus 5 equals 4 times 5. 3x plus 15 would equal 20.
3x equals 5. X equals 5.
5 over 3, or 1 2/3. And that's one of those cases where you'll leave it like that because that's a decimal that has to round, and you don't want to round it. Questions? So first of all, we had to say that the triangles are similar, and if they're similar, their sides are proportional. Probably if they're asking you for an x, they are going to be similar. But if the directions said, like, if you cannot find, if there's not enough information state so, then that's a possibility that they're not similar and then you couldn't find it.
So, wait, you said if the question asked what you mean?
Like if it said find x, if there's not enough information state so, maybe they're not similar. Maybe you're missing that parallel lines and you wouldn't know that they're similar. Mm-hmm.
Do column proofs gonna come back in this chapter?
A little bit. A little bit. Not bad. This is... All right, example 3. Okay, again, you've got a figure on the right, and again, you've got parallel lines marked. So I would know that this is congruent to this and this to this. So I know these are similar. It already gave me A, B, C, so I got to go in that order. 1 arc to none arcs to 1 arc, which means on the small triangle, I have to go, 2.
Wouldn't the B could be 3 arcs? 'cause it's
Sure.
reflexive.
Yeah, you can mark it if you want. You know that this is reflexive and also third angles, so that you can mark. So then when I look at the small triangle, I have to go in the same order. It would be E, then B, then D. Has to be in that order. Now I have to figure out the missing side lengths. So I've got to figure out what of my triangles. So if you wanted to like redraw these, you totally can. Okay, that red triangle would be 3, 4. That's a 3, and then this is the Y, and then the blue triangle, the big triangle, I can redraw.
Wait, for y, can't you use the mid-segment theorem together? Or
No, because it's not the midpoint. So good question, but D is not the midpoint. If it was 3 and 3 and 3 and 3, yeah, but you don't know that that's the midpoint. So this side would be 7 because it's 3 plus 4. This side would be x plus 3, and this side would be 8. So if you want to separate it out, you can. Okay, if you get confused by looking at the whole, you can definitely separate it out. So now, which of the side lengths do you have a ratio where you have both?
7, 4.
7 and 4. So it doesn't matter which direction I go because it's not asking for a scale factor. I can do 7 to 4, or I could do 4 to 7 as long as I'm consistent on the other half of my proportion. So if I did 7 to 4, that's right triangle or blue triangle, big triangle to left. Then I would continue on in that pattern, and I would say x plus 3 over 3. If I had said 4 to 7, then I would have said 3 to x plus 3. So as long as you set it up and you're consistent, it doesn't matter. Now this is 21 equals 4 times x plus 3. 21 equals 4x plus 12. X x equals 9/4, which is 2 1/4 or 2.25. I would have gotten the same answer solving the other one. Now I got to solve for y. So again, I can do 7 to 4. As long as that's big triangle to small triangle, I follow that suit in the next part, which would be big triangle, which is 8, over small triangle, which is the y. And then I want to cross multiply.
So 7 equals 32.
And that's 4 4/7. And then the last thing says BE, which is this side here, over BA, which is the big side here, would equal, and there's a lot of answers you could put here, but I could do DB over CB. I could do DE over CA. Or I could do 4 to 7. So it wasn't really specific. If it said give the ratio of all the sides, then I would know to do the first two. Okay? If it said give the scale factor, you would know to do the last one. But really, any of those answers are right.
So you can do 4 to 7.
Yeah? Questions?
Oh, you're not solving it, you're just saying what you
Yep, you're just figuring out what the ratio would be. Okay, last one. Here you go, Mateus. Given AC is parallel to BD, prove triangle AOC is similar to triangle BOD. First of all, we only know one way to prove triangles are similar right now, right? Which is the angle-angle similarity. So that's basically what we know where our proof has to go. Our proof has to show that two pairs of angles are congruent, okay? Eventually, we're going to learn a couple more tomorrow, and it will get a little bit more challenging because you got to figure out which ones they are. But right now, all we know is angle-angle similarity. So I know my given is AC is parallel to BD. That's this would be given. And the last step is going to be what?
Your AA similarity.
Good. AOC is congruent to BOD. And the reason is going to be angle-angle similarity. What I got to do is prove the two pairs of angles in between. Brayden.
Vertical angles.
Good. So this is the easiest and most obvious in my opinion. Go back to that stuff. Check for the easy stuff. So AOC, you can't say O because it's shared. So AOC is congruent to DOB, and that's the vertical angles theorem, not definition of vertical angles, but vertical angles theorem. That gets a lot of you a lot of times. So now I got one pair of angles. Then what? Go ahead, Brandon.
Parallel lines.
Good. So because these are parallel, and you can use this transversal, I could say that this is congruent to this, and that's alternate interior. So I can say angle ACO is congruent to angle BDO, and that's alternate interior angles theorem, which said that if lines are parallel, then alternate interior angles are congruent. You also could have said the same about angle A and angle B because this could have been your transversal, okay? It would have been alternate interior. You only need one of them though. It could have been, instead of vertical angles, I could have done both alternate interior angles, or instead of that pair of alternate interior angles, I could have done the other one.
So you could have proved that.
I could have said angle A is congruent to angle B instead of this, or instead of the vertical angles.
So we're just talking.
And now I've got two pairs of angles, right, that are congruent, so then I can go straight to that proof statement. And the reason is angle-angle similarity. Yep.
Should there be a proof on the quiz?
Actually, no, there's not a proof. There's not like a full-on 2-column proof on your quiz. It'll probably be
Like
on your test.
So you fill out portions.
There could be like a yes, it's,
Oh.
or no, and then why. Because we're going to add to angle-angle similarity tomorrow. You're going to see there's more methods, more shortcuts. Okay. Questions? All right, let me publish.